So far in this course we've been talking about angle measures in degrees. Well, from now on we're not going to use degrees in this course. We'll use it sometimes, but not too often. We're going to use a new measure of angles called radians. So today I'd like to define what a radian is for you. Okay? First of all, I want to define a central angle. Now an angle whose vertex is the center of a circle is called a central angle. That's all there is to a central angle. Now we're used to graphing angles using a Cartesian coordinate system. Okay? All we're going to do is we're going to attach a circle on it. All right? So here's a circle on my Cartesian coordinate system. Now a central angle is simply an angle formed with the vertex at the center of the circle. And that's it. So theta, in this case, is my central angle. Now, we'll call this little piece of the circle an arc. And we'll give it a letter S. So the angle will always intercept the circle at an arc. Okay? So we'll call this an arc. Okay? But that's what a central angle is. Okay? Pretty simple. It's just an angle, but we're going to have it centered in a circle. All right. Let's define a radian. Now this is a little bit tricky, so I'll go real slow. You might want to pause here and write down the definition. But a radian is the measure of a central angle that intercepts an arc of equal length to the radius of the circle. Now let's go ahead and give my circle some dimensions here. Let's say that the radius of my circle is r. Okay? So from here to here is r, from here to here is r, etc. So that would be the point r, right? That's r to there. This would be negative r units over there. This would be another negative r units there. Okay. Now, let's try to figure out what a radian is. It says a radian is the measure of a central angle that intercepts an arc of equal length to the radius, which means that if I draw an angle, okay, this length is r, this length is r. Now the arc must also have a length of r. That measure, that angle, is called a radian. Okay. Let's see how many radians there are in a circle. Okay. Well, here's one radian. So I'll have to draw that same angle. I'll try. Maybe about to here. There would be a second radian. There's a third radian. So we have one radian, another radian. There's another radian. Maybe a fourth one here. Trying to draw the exact same angle. There's 4 radians. There's a 5th one. And there's a 6th one. And we have a little bit left over. Actually, there's about 6.28 radians in a circle. And we'll see the significance of that number in a second. So a radian is just the measure of this angle that has the same intercepted arc length as the radius of a circle. Okay, so it's a little confusing. Let's figure out the relationship between degrees and radians. Okay. First of all, let's say that this is a circle with radius r. Okay. So I have a circle of radius r. Let's recall. What's the circumference of a circle? Remember the circumference of a circle? Well, the circumference of a circle, the formula, you've seen it somewhere, but I'll refresh your memory, is 2 pi r. Okay? Now, let me go ahead and draw a radian. So we have one radian here. Remember, this arc, if I have a radian here, must also be a length of r units. All right. So I can come up with this little formula here. Okay. I have 1 radian is to r, okay, a length of r, as, well, how many degrees are there in a circle? We know that there's 360 degrees. Okay, so one angle of 1 radian is to r, as 360 degrees is to the total length around the circle, which is 2 pi r. So I've set up this little proportion here. And now I'll do a little cross multiplication, little algebra. 2 pi r radians over, well, let's just go ahead and cross multiply here. 2 pi r radians this way equals 360 degrees times r. Okay, and I'll do a little algebra. Notice my r's cancel. I can divide both sides by r. And I'm left with 2 pi radians is the same thing as 360 degrees. Okay? Now, this should make sense here in a second, because remember what pi is? The number pi was roughly 3.14. Remember, that decimal goes on forever, but we usually round to about 3.14. So 2 pi is going to be approximately 2 times that, or about 6.28. So 2 pi radians is about 6.28, okay? And remember how many radians there were in a circle? 6.28, okay? So the relationship is 2 pi radians is the exact same thing as 360 degrees. Now I can do a lot with that. 1 revolution of a circle will be the same thing as 2 pi radians. Or 360 degrees is the same thing as 2 pi radians. Now what's going to happen when you divide this by 2? 180 degrees is going to be the same thing as pi radians. And this is the one that we'll most often use right here. Okay? So if I asked you, sketch an angle of theta equals pi, okay, that's the same thing as sketching a 180 degree angle. So there's an angle of pi. If we said sketch the angle theta equals pi halves, well, if 180 degrees is equal to pi, then pi halves is equal to 90 degrees. So here would be theta equals pi halves. Now we'll practice this in subsequent lectures. But what you need to get from this is you need to know what a radian is. Okay? You need to know what the definition of a radian. Okay? A radian is the angle whose arc, okay, intercepted arc, is the same length as the radius of a circle. And you need to know that 180 degrees is the exact same thing as pi radians. And we'll use this in the upcoming lectures.